In this video we're checking out the OWLRC SWR meter. This is an updated version that was reviewed about a year ago by a lot of people, but this one here obviously looks quite a bit different. If you look at the old reviews, I think that one was more of a prototype with I think it was a wooden box or something like that. This is all metal. Has a 12 volt input here on the right hand side. It only runs off of 12 volts. It does come with a barrel plug connected with an XD60 if you want to use a 3S LiPo. Got an on-off switch here. There's nothing on the bottom or the back, and then you just have a single SMA antenna connection here. Basically, what's inside here is a video transmitter, and that's how it tests the various antennas. The antennas that you want to connect on here they have to be SMA antennas, or you have to use some sort of an adapter if you want to use some other kind of an antenna. And then when you power it on, you get two modes here. You get real-time mode and scan mode. And if you want a little explanation of what each of these does, just click the little button here. This is a touch screen, and there's an explanation of what real-time mode is. I'll actually demonstrate it. You can pause the screen if you want to read this. And this is the help for scan mode. And again, I will also demonstrate this, so you can pause the screen if you want to read the description of what the scan mode is. Okay, so go ahead and we'll go into the real-time mode here. Actually tests 8 channels on, I think this is the E band, starts at 5645 and it goes up to like 5917, I believe. And the way SWR is measured is basically a ratio of the I guess the forward value versus the return value of how much is basically the transmitted power versus what's received back, and that gives you an SWR. And you want something that's going to be low, ideally around 1, so basically everything that's sent out is not reflected back. That's essentially what you want from a good SWR reading. And let's go ahead and we'll turn this on. The light turns green, which means it's now transmitting on this antenna here. This is just a stubby antenna here. It's just an indice stubby antenna. Anyway, it shows here the value of the forwarded, the transmitted value of 1, and then the return value of 0.04. So you get a SWR of 1.08 on this frequency for that antenna. And while it's on this real-time scan mode, it will actually show you the values here over a period of time. It's not going to fluctuate too much here. As you see, it's adjusting a little bit, but it's going to generally stay about the same. They do recommend that you have this powered on for a few minutes, which I have, to give you a more consistent result. But then you can see as it warms up, the number should go down a little bit. And this is on the lower end of the band. And if you click this little button here, which is a little hard to hit, there you go. This is on channel 2, 5685, and the numbers are going to be different. And you can actually go through each of these one by one. I actually don't prefer this mode because it's I'd rather see all of the whole range of the band. So we'll go ahead and we'll stop this here. I'll show you. You can just actually go through each channel one by one, but the other mode, the scan mode, will actually go through the whole band. You don't have to actually go through one channel at a time. So we'll go in here, and you just have to hit track and auto, and it will scan through the entire band, 5645 through 5945, and this gives you the SWR number as a graph here. So you can see it starts low, gets a little bit higher, and gets low again. And this is the characteristics for this antenna on the band, your SWR numbers. So each antenna is going to have a little bit of different characteristic, but this is kind of what you're looking for. This is a pretty good antenna here. You're going to get consistent results across the entire band. You'll see, I'll show you a couple other examples. Some antennas are going to have better results in the lower end, worse in the higher end, and vice versa. So let me go and switch this antenna out, and I'll show you another example. Okay, swap the antenna out here. This is actually a Foxier, I think it's a Pagoda Pro antenna with a long lead here, so it's for like long range. And go into scan mode, and we'll hit track and auto. The track actually shows you where the lowest number is. They'll give you a little white, sorry, it's a yellow line there as to what the lowest value is on the entire band. So this run, it'll just basically scan through the whole band again. So it might change a little bit as the temperature changes, but it's already warmed up, so it shouldn't change too much. You can see here, yeah, sorry, it's the red line here. That's the marker that shows you the lowest SWR. So it shows you the lowest SWR, looks like it's a 5771 at 1.33. And it's like right there. So it's kind of, it'll give you an idea of where you want to probably use the antenna. And I think this is, SWR is probably going to be more for how good it is as a transmitting antenna and not necessarily a receiving antenna. I don't know if this is, SWR is necessarily a good measure of that as well, but this is, I think it's more for how it is as a transmitter. Okay, so let me give you another antenna as an example. Okay, I got another antenna here. This is the Emacs Nano antenna. And let's go ahead and see what this is like. So as you can see for this antenna, these numbers aren't very good. They're all above 2, a little bit better on the lower end of the band, but also but quite a bit worse up to 4 on the higher end of the band. So this is probably one that you may not want to use as a transmitting antenna. But let me just show you, I have another one of these. I use this as an example because you're going to see variation amongst different antennas. And by the way, like if you grab the antenna here, this will totally affect the antenna's characteristics. You can see the numbers change here in real time. See how the graph changes. If you don't want it to be doing that, you don't want any, this touching any metal objects or anything like that. You want that to be obstruction free. So this is generally what the graph will look like for this antenna. But keep this in mind because I'm going to actually get another one of these and we'll do the same test and you'll see that you get some different results. Okay, so I got another one of these nano antennas here, and this one here is quite a bit different. You got much better readings in the lower part of the band, but much worse readings at the high end of the band. So obviously this will give you an indication. This is what's good about this particular meter is it will give you the characteristics of that specific antenna. So you'll know where you want to probably use it. You probably want to use it here in the lower end of the band and not use it in the upper end of the band. So it's because not every antenna is made exactly the same, and so I found that as you test antennas, you're going to see some variations. So yeah, this I don't know. I mean, to me, it kind of throws all of those VTX antenna, I'm sorry, VTX tests I guess you see out there kind of into question because you kind of wonder, well, which antenna are they using and what part of the band are they using? Because there's variation in antennas. Like if they're using, that's some sort of a luminaire antenna, how consistent is that across all the ones that are manufactured? Now, I don't have every possible antenna out there, but this is just one example I'm showing here where there's an inconsistency in, I guess, manufacturing of the antenna. So just be aware of that, and that's kind of why that this SWR meter is kind of interesting and kind of useful at the same time. Okay, I'm going to show you one more example. This is the Amway. This is an old antenna, circular polarized antenna. And you can see these are some pretty good results too, but still not as good as the Nadisi stubby antenna that was on there originally. That was probably one of the better antennas, surprisingly, and that's actually a pretty cheap antenna too. So yeah, don't necessarily think that more expensive antennas are necessarily better. Of course, then there's going to be people that are going to be questioning whether or not this meter is accurate, and the company even says this is a hobby grade, I guess, testing equipment, so not engineering grade. So take that for what it is. But this will give you sort of an idea of, like, at least of the antennas that you have, which ones you may want to choose to use and which ones you may want to use for other things. So I think that's what this could be useful for. If you have some bad RF, bad video, you can use this to find out what's going on with your antennas and have an idea of like where you would want to use the antenna. So if you say, for example, like this one's pretty consistent across the whole band, so it's not a good example. But the last antenna where it was worse in the higher end of the band, then you'll know that, oh, that's why I have bad video, because maybe I'm using some frequency channel up in the high end of the band where I should be using a channel in the lower end of the band to get better video. So I think that's where the value of this meter is, not necessarily to find out the absolute best antennas out there, but just maybe give you an idea of which antennas you have are good. So I think that's what this would be useful for. Anyway, that's going to do for this video. If you want to see more testing results, obviously I have a lot of antennas, but I'm not going to sit here for hours and show you every single antenna that I have. Leave me a comment below if I have that antenna. I'll take a photo of this and post it somewhere where, I'll post a link to the question or the antenna that you're interested in, if there is enough interest and if I have time. So yeah, there's a lot of interest in a particular antenna. You guys, make some noise down in the comments, let me know, and then I will respond with a link to a photo like this of that antenna. At least it'll be the results from my antenna that I have. Of course, if you have that same antenna, your results might be different. So take that, keep that in mind, that it might necessarily be the same, but it could give you an idea of like generally how that antenna might perform. Anyway, guys, that's gonna do it for this video, and I'll talk to you guys in the next one.